Before we get started, let's take a moment to talk about safety. Although most professional concrete workers have never had any problems, wet concrete can cause chemical burns in some circumstances. You'll see workers in this tape who are highly skilled but are not observing all of the proper safety guidelines. The best way to avoid problems is to take some simple common sense precautions. The key is to keep wet concrete from coming into contact with your skin. Start with the right clothing. When you're working with fresh concrete, this means full-length pants and a long-sleeve shirt. And don't roll the sleeves up. Use waterproof gloves and rubber boots high enough to keep the concrete out. When you're placing concrete or sawing concrete, wear goggles to protect your eyes. If you're using a saw, wear a dust mask or respirator and earplugs. When using curing compounds, follow the manufacturer's instructions. Solvent-based curing compounds may require the use of a respirator and other personal protective items. Fewer safety precautions may be necessary for water-based curing compounds. And don't forget to wear your hard hat if there are any potential overhead hazards or lateral movement of equipment in your work area. Follow these simple rules, and you'll always be dressed for safety. Joints are a very important and necessary part of any concrete slab work. Joints are used to minimize random cracking, to isolate sections of different shapes or sizes, or to separate slabs from fixed objects. Therefore, in order to plan for making joints that are not only pleasing in appearance but functional as well, it is important that we understand the causes for random cracking in concrete slabs and how random cracking can be controlled by proper jointing. Most random cracking in concrete slabs is caused by drying shrinkage. Drying shrinkage is the result of mixed water leaving the concrete as the concrete cures and hardens. The primary factor influencing the amount of drying shrinkage is the initial water content of the freshly mixed concrete. Drying shrinkage increases directly with increases in water content. To keep drying shrinkage to a minimum, do not use more water in the concrete mixture than is necessary for proper placing and finishing. Let's look at what happens in a concrete slab as a result of drying shrinkage. If a concrete slab 100 feet long was free to move without resistance to its drying shrinkage, it would shrink about 5/8 of an inch. We know, however, that the movement of a concrete slab is resisted by the ground it is placed on, and it is this resistance to drying shrinkage movement that causes the concrete to crack. We use joints, then, to control where the concrete cracks, beneath the joint. There are 3 categories of joints that can be used to control cracking. They are referred to as control or contraction joints, isolation joints, sometimes called expansion joints, and construction joints. Let's look at each one of these joints in turn and see how they function. Control joints make the slab thinner at the joint location. This forces the concrete to crack beneath the joint and provides a pleasing appearance on the surface of the concrete. In sidewalks, driveways, patios, garage floors, and basement floors, control joints are usually produced during finishing operations by hand forming with a special tool called a groover. Control joints can also be produced by sawing a groove into the concrete as soon as the concrete has hardened sufficiently to prevent aggregates from being dislodged by the saw, usually within 4 to 12 hours after the concrete hardens. If sawing is delayed too long, the concrete may crack before it is sawed, or cracks may develop ahead of the blade during sawing. As a safety precaution, wear goggles, a dust mask, or respirator, and earplugs when sawing concrete. Regardless of the method used, to be effective, the depth of the joint must be at least 1/4 the slab thickness. Unfortunately, there are no calculations that can be used to predict the precise location or spacing required to control cracking. There are general guidelines, however, and if followed, They are usually sufficient to control cracking. In narrow slabs, such as sidewalks, joint spacing is short, usually equal to the width of the slab in order to keep panels as nearly square as possible. A 1 1/2 to 1 panel is permissible, however. Spacing of joints in patios should not exceed 10 feet in either direction. Sidewalks, driveways, and garage slabs wider than about 10 to 12 feet usually will require a longitudinal center joint to prevent random cracking. Transverse joints would then be spaced at regular intervals in order to provide nearly square panel shapes. Longitudinal center joints and transverse joints should also be used in basement floor slabs to prevent random cracking. In general, all control joints should be continuous across the slab. If staggered or offset, the joint will induce random cracking in the adjoining panel. Control joints should also form right angles with slab edges whenever possible. This will prevent cracking at narrow sections where joints make sharp angles with slab edges. The use of welded wire fabric, sometimes called wire mesh, is usually not required when properly spaced control joints are used to control cracking in concrete flatwork. When wire mesh is used, its function is to keep random cracks tightly closed after they form. Isolation joints separate a slab from other parts of a structure and permit horizontal and vertical movement of the slab. They should be used wherever a sidewalk, driveway, patio, or garage slab abuts a building or fixed object, around box outs for manholes, and where slabs of different width or thickness meet. Isolation joints should also be used around the perimeter of a basement floor to isolate it from the foundation wall, and around any column or object that penetrates the floor. Isolation joints can be produced by inserting a joint filler material before or during concreting operations. Filler material can be as thin as 1/4 inch or less, but 1/2 inch filler is commonly used. Care should be taken during construction to assure that the filler material extends the full depth and width of the slab in order to provide complete isolation. A joint that provides only partial isolation will not function properly. Construction joints provide a transition between one day's work and the next. Construction joints in sidewalks, driveways, and patio slabs are usually designed and built to function as control or isolation joints. There are times, however, when tied construction joints are used to prevent differential movement, such as when redwood forms, left in place for architectural effect, divide a patio slab into smaller units. Tying is accomplished by inserting 2-foot-long pieces of number 4 rebar every 16 inches on center through pre-drilled holes in the side forms. The rebar must be clean of all oil, mill scale, and rust, and be installed parallel to the top surface of the slab. Remember, random cracking in most concrete slabs can be prevented by carefully planning the types of joints and joint locations required to accommodate the shrinkage changes that occur in concrete. This has been a presentation of the Portland Cement Association and the Aberdeen Group.